today in this video, we'll start discussing the final topics, including the surface tracing, parametrization, multiple integration in 3D, which of course involves the double and triple and non-elementary integrals and the change of variables, and then the vector analysis. So under this vector analysis, we'll be discussing the line integrals, Green's theorem, divergence theorem, and then the Stokes theorem. Of course, kung masyadong saturated, then we'll try to skip some parts kung hindi talaga kakayanin. But let's start the discussion by having a review of the 3D plane. So as you can see, we need to understand muna yung ating 3D plane bago we can start parametrization, the vector calculus. And I don't think ito ay sobrang bago na sa inyo kasi noon sa finals ng DiffCal, I still remember na I've already introduced the XYZ plane. But let's have a recap. So I'll be showing you the GeoGebra and then hopefully you can visualize it na mas madali. So this is the XYZ plane, and usually the XYZ plane is a right hand or the left hand, depende lang kung nasan yung x-axis. But in this case, I'm using or will be utilizing yung ating right hand XYZ plane. So pag right hand, nandito yung ating positive x, ay, ibahin natin ang kulay. So nandito yung positive x natin, this is the negative x, this is your positive y, this is the negative y, this is the negative z, and this is the positive z. So of course, this is a 3D plane. So meron tayong xyz pag gusto natin mag-plot ng points. So let's have a recap on how we plot points sa xyz plane. Suppose I want to plot, let's say, negative 2 and then 5, let's say 3. Okay, so that means na meron akong negative 2 units sa x-coordinate or x-axis. Meron akong 5 units sa y-axis and then 3 units sa z-axis. So, kung gagawin ko yun mano-mano dito sa ating xyz plane, so you can just look at this value. So, we have negative 2. So, diba, this is your negative 2 and then 5. So, that is something like negative 2 and then 5. So, basically, nandito yan. Pero syempre, kung gusto natin ng eksaktong-eksakto talaga, I can draw a line that's parallel to the y-axis muna. So, pwedeng ganyan. And then, I can draw another line that's parallel to the x-axis tapos magta-touch yung 5. Para yung intersection, I can guarantee na yun yung ating 2 or negative 2, 5. So, parang ganon. Now, I don't require you to do this. Siyempre, pwede naman niyang by inspection na lang gawin, no? Kaya naman din yan eh. So, it's around here. So, this is negative 2, 5. Pero, we have to remember na aakyat tayo ng 3 kasi that's positive 3 units sa z-axis. So, basically, we can plot it somewhere here kasi, diba, this is 1 unit. So, parang aakyat ka lang dyan. So, dito na yan. Okay, so parang meron tayong 1 unit dito. 2 units and then, so probably, I'll be assuming na this is the correct point. Kasi parang around 3 units to. Or medyo, parang maliit-liit pa to. So, around here. Or maybe here. Okay. So, that is my assumption based on using the 3D plane. So, ganun lang. Gagawa lang kayo ng mga parallel lines. And then, finally, dun sa Z, you have to project upward or downward, and then syempre, yung pagbibilang nyo based dun sa pinanggalingan ng corner. So, gawin natin, i-plot natin siya dito sa ating GeoGebra. So, that's a negative 2, 5, and then 3. Okay, so yun, medyo hindi pa natin nasakto yung yung point, but the concept is the same. So, yun, kaya kung mapansin nyo yung 3 units dito, so parang, di ba ito yan? Pag kinonect nyo tong 3 dito sa point na to, mapansin nyo, hindi siya parallel dito sa positive y. Kasi nga, it doesn't mean na kasi na parallel siya dun sa, magpaparallel siya dun sa y kapag kazi na yan. Kasi ang pinaparallel lang natin usually is yung x and y, and then pa-project natin upwards or downwards yung z coordinate. So, that's it for the plotting. I hope na tandaan nyo pa yan. Again, hindi lang points ang pinaplot natin sa XYZ plane. And even sa XY plane, meron din ito. Meron tayong mga tinatawag na vectors, which of course, alam naman natin na vectors, sila yung may mga magnitude and direction. Usually, this is represented by an arrow, and meron tayong endpoint at saka yung ating arrowhead. So basically, if I want to draw a vector, let's say, the vector has the directional values at -1, -1, 0. So basically, ang representation natin ng vector is a bold letter, small letter. So for example, I want to represent the vector v as this one. So that is vector v, and then lalagyan nyo lang ng parang this symbol. Hindi naman siya less than, pero parang bukang less than. I don't know what it's called. So let's say it's 1, 2, 3. So the vector locations are 1, 2, 3. So kung gusto nating i-plot yan, so remember that's you can just count parang ito 1 unit and then 2 units sa y and then 3 units around here. So technically from the 0 or the origin of this xyz, so gagawa ka ng vector na kumo-connect dun sa origin papunta dun sa point na yon. So technically, if you want to look at this, we can have v is equal to 1, 2, 3. Sorry. Okay. Let's have the small v. Okay, so that's how it looks like for the vector quantity. So this is a point in the Cartesian coordinate system in the xyz plane. This is a vector in the xyz plane. So I hope you can understand the difference between these two. Kasi napaka-importante nito when it comes to a point na we have to understand parametrization. Okay, so let's go back to the module and let's see what's next. So this is the distance that can be solved if you're given by a certain point in the xyz plane. So for example, meron kayong negative 1, 2, 3, and then meron kayong 7, 5, 8. So you just have to take the differences for each coordinate na yun. So individually, we have the difference for x, y, and z, and then you just square them, and then you can just add the squares of the difference, and then you will get the distance. So I think na yung nasa handout is cubed to, so paki-correct, that should be squared. So wala namang pinagkaiba to dun sa distance formula dun sa ating xy plane. Ang nadagdag lang talaga dito is itong portion na to. So from that, just add this last part of the equation, and then that's just the distance formula in the xyz coordinate. And for the sphere, so itong sphere na to, it's like the circle in the xy plane. So pag sphere naman, lalagyan lang tayo ng z minus zo squared, which is equal still to r squared, kasi yung r is the distance from the center of this sphere. So basically, that's still r, and then nadagdagan lang tayo ng isang other variable. Ganun lang kasimple yung additional natin ng contents nitong ating xyz plane from the xy plane. And then if you want to find the midpoint of the line segment that joins any 2 points sa ating xyz plane, so that's just the same. Take the average of those 2 points and then you will be getting the midpoint. So what about vectors? Ano ba yung mga properties ng ating mga vectors? Kasi we're talking about points kanina. So vectors, let's say we have a vector u and vector v. So meron akong dalawang vectors. Imagine meron akong dalawang parang may arrow na dinrawing sa ating xyz plane. So the equality of vectors states that the only way we can say that two vectors are equal if and only if u is equal to v. That is, all the values of yung u at sa v ay the same. So let's take for example this one. If the values of u for this case, let's say for 7, 8, so meron akong v, this is equal to let's say 1, 2, 8, and then meron akong w, so this is equal to 4, 7, negative 8, and then let's have the last one, let's say x. So this is 4, 7, 8. So basically, the only case wherein we could say that two vectors are equal if all the elements inside this are the same. So basically, kung 4, 7, 8, dapat 4, 7, 8 din sa rest. So this one doesn't tally with the previous one. Also this one. So ito lang yung magiging equal sa ating first vector. So therefore, u is equal to x. That means na same lang yung tinutukoy natin na vector for this particular case. Okay, and then the next one is the component form. So if v is represented by the directed line segment from 2 points, then the vector is equal to the difference between these 2 points. So yung mga values ng vector na yun, pwedeng we can write them as a difference ng mga values sa points. So yan. So ano ba ibig sabihin nun? It doesn't mean na yun na yung vector na tinutukoy niya na pag pinagdikit mo yung points na yun, yun na yun. Ang ibig sabihin lang nun, for example, meron tayong dalawang points. Let's say 1, 0, and then let's have 2. So these are the 2 points, A and B. So I want to find a component vector for these 2 points. So I'll just have to subtract yung ating B to A or A to B. Either way naman, pares lang yon. Magkakaroon lang tayo ng ibang direction ng vector, pero that's just the same concept. So for example, ang gawin nating reference is yung A going to B. So therefore, that's B minus A. So let's have V is equal to B minus A, that's 3, negative 5, and then negative 1. So as you can see, this is the vector obtained from these 2 points. So ano bang pinagkaiba niyan? Ano bang pinagkaiba nito sa dalawang to? So if you would be looking at this, kung halimbawa nag-trace ka ngayon ng certain line from these 2 points, I want to trace this line. This vector is parallel to this certain directed segment. So yun yung ibig sabihin ng ating component vector na pag pinag-subtract natin tong dalawang to, the line that will be formed is actually parallel to that a certain segment na nag-connect nung dalawang line na yon. It doesn't mean na ito na mismo yung vector na yun kasi nga pag sinabi natin na yun, ibig sabihin yung point na isa dyan is starting with 0, 0, 0. Pero hindi ganun yung case. Pero we could assure na this one is parallel with this A to B. And of course, yung mga component nun along the XYZ plane of this line would of course be a component based on the parametrization of this vector na nakuha natin. So yun. And that's it for the component of the vector. And then we can proceed with the length. So, ito naman length, hindi na to bago sa inyo, no? If you want to determine the length of a certain point from the plane, so, for example, this line A, so, technically, the distance, or yun B na lang para mas malapit. So, yung distance nitong B, so, from 0, 0, so ito yun, yung distance na yan. And if you want to compute for that distance, you just have to take the square of X component, and then the square of the Y component, and then the square of the Z component. So, ganun lang siya, like the distance formula. And then, the unit vector in the direction of V. So, ano ba itong sinasabi natin na unit vector? So, sometimes, yung ating mga vector is, hindi sila unit vector. So, for example, this one. This vector is not a unit vector kasi kung mapansin nyo, yung distance or yung length ng vector na to is more than 1. An example of a unit vector is this one. Halimbawa, nag-drawing ako ng vector na to and then ang sukat lang niya is 1. So, therefore, that's a unit vector. And how do we determine how do we make a certain vector a unit vector? So, let's take this 1, for example. This is not a unit vector, pero siya is 3, negative 5, negative 1. Sabi, that is the you can take all the values of 3, negative 5, and negative 1 and then divide it by the absolute value of the V, or simply the distance between these 3, negative 5, negative 1. So, ano ba yung distance yan? That's simply the square root of 3 squared plus negative 5 squared plus negative 1 squared. Okay? So, therefore, the unit vector in this case would be, let's say, the unit vector U would be equal to, ano ba yung mga values? So, that's 3 over, ano ba tong value nito? So, that is square root of 35. So, that's square root of 35. And then we have negative 5 square root of 35. And then negative 1 over square root of 35. So, this is your new vector. And if you'll be plotting this unit vector in our graph, so we have 3 over, okay, so you could see it from here na this U, let's say, ganito yung kulay niya. Or this one. Ito na lang. Yan. So, mapansin nyo, the unit vector is parallel to the original vector, pero pag tinek nyo yung distance yan, that's just 1 unit. So, yun yung essence ng unit vector. Parallel siya dun sa original vector, and then that's just 1 unit. Parang pinekli natin tong vector na to na mahaba. Okay? So, yun. And then, the next property is the vector addition. So, you can add two vectors for as long as they have the same dimension, of course. Kung halimbawa, nasa 3D plane tayo, so meron tayo XYZ. So, kung tatlo lang din yung isa, you can add them. And then, just add the corresponding components. So, kung X siya, di X. Kung Y, and then kung Z, edi Z. And then, for the scalar multiplication, if you have a vector, let's say, 175. So, vector V is equal to 175. and then you want to multiply this by scalar multiplication, let's say 3v. So therefore, this is equal to 3, 21, and then 15. So you just have to multiply individually the components by the scalar multiple, which is the constant. Okay, so that's it for the concept of the vectors in space, and those are the properties of vectors in space. So I think we can now move with the parametric equation and how this parametric equation or parametrization is related to our future discussions. But I think the very first discussions here would just be finding the set of parametric equations from a given or from two given points in the XYZ plane. So this is a very easy topic. Now from this part, sabi dito, a parametric equation defines a group of quantities as functions of one or more independent variables called the parameters. So if a smooth curve, this is the smooth curve C, is given by the equation x is equal to ft. So meron tayong x dito, and then nakita nyo naman na the variable is t. We also have the the y, which is in terms of t din. So the derivative with, of course, is still dy over dx. So the parametric equation can be written in a sense na pag meron kayo x and y and then gusto niyo na siyang magkaroon ng isang variable, represent natin siya as isang variable, then that's just the parametric equation. Parang gagawin lang natin, transform lang natin yung x and y in terms of a single common variable with the two variables, previous variables. So for example, ganito siya ginagawa, no? If you have a vector v, a, b, c, that's the direction number obtained from the difference between 2 points. So you can actually have that direction number multiplied with yung gusto mong variable, and then you add the initial point that you've already selected. So for example, meron kang PQ. So yung P, let's say meron kang dito, balik tayo. So let's say meron kang ito na lang, point A and point B. So gusto mo is you find the parametric equation from these 2 points. So what you have to do here is to determine yung ating tinatawag na direction vector or direction number, and in this case, this is the direction number 3, -5, -1, kasi that's the difference, no? And then after that, to determine the parametric equation, you can write x would be equal to your x1 plus at, and then your y would be y1 plus bt, and then the z would be z1 plus ct, wherein t yung ating ginagawang variable parang for the parametric equation, and then ano naman yung ating x sub 1. So therefore, yung x sub 1 mo is the value wherein ginawa mong reference. So ano ba yung ginawa natin ditong reference? So pinagsubtract natin is 1 minus negative 2. So therefore, the reference is -2. That's a. So x sub 1, y sub 1, z sub 1 would be equal to this -2, 5, 3. So from this, let's have the first number. And it says here that we have 2 points, -1, 2, 5, and 3, 0, -4. And then let's find the parametric equation from these 2 points. So sabi natin, we can determine the direction number by having the difference between two points. So assuming na I start with A and end up with B, so therefore yung A ko yung magiging reference natin na parang ito yung magiging x sub 1 natin, and this would be your x, parang ganon. So from this, we could just say na ang ating direction vectors would be the difference between B and A. So that's 3 minus -1, and then 0 minus 2, and then -4 minus 5, which gives me the values that are 4, -2, and then -9. Okay, so these are my A, B, and then C. So from these values, I can generate the parametric equation for x. So x would be equal to x sub 1. So ano ba yung reference ko na first point? So that's -1. So diba sabi natin x is equal to x sub 1 plus at. So that's -1 plus a is 4 and then t. So therefore, this is the first parametric equation for x. And then for y, we have y sub 1 plus bt. So y is equal to negative. This one is positive 2. So 2 plus bt, so -2. Okay, and then finally z is equal to z1 plus ct. So therefore, z would be equal to 5, 5, and then plus c would be negative 9, and then t. So therefore, these are the parametric equations for these 2 points, A, B, C. And then if you want to determine the, actually the question is what are the symmetric equations pala. So hindi pa pala ito yung sagot kasi these are the parametric equations. So pag symmetric equations naman, so you can just represent lahat ito in terms of t. So parang t is equal to t is equal to t from each x, y, and z. So therefore, diba this one, t would be equal to x plus 1 over 4. So ganon. So for the first one, we have x plus 1 over 4. This is equal to the t value for y. So that is y minus 2 all over negative 2. And this is equal to z minus 5 over negative 9. Okay, so these are the symmetry equations. Mayroon pala dito set of parametric equations. So ito pala yun. So these are the answers. So you might be thinking, bakit iba tong sagot ko dito sa nasa solution na nandito? So ito binago ko na rin to ha. So itong solution na to, lagi kang pwede makakuha ng dalawang solution sa parametric equations. Whichever is your reference point. Kasi kung halimbawa, A ang reference mo, so therefore, ang x sub 1, y sub 1, and z sub 1 mo is mababago. Unlike this one na ang ni-reference natin is yung B. So therefore, for this case, yung values ng ating point B yung magiging natin, reference. So, the ABCs have the same magnitude, absolute value nung kahit negative, para sila magnitude. But then again, the values of x sub 1, y sub 1, and then z sub 1 would be different kasi magkaiba tayo ng ginagawang reference point. So, these are the symmetry equations. It's either this one or that one. Basta, depende yun sa reference yun ng points. Okay? So, that's it for the easy parametrization of 2 points. So, pas may 2 points kayo, just designate A and B and then determine the parametric equations. So, we can now move forward to planes in space.